and go ahead.
So I should share my screen, right?
Yes.
Okay.
Good afternoon, all of you. Now we are going to start our talk on the topic peer-to-peer energy trading in active distribution networks by Professor Sanjoy Debbarma. But before that, I am honored to read a short biography of Professor Sanjoy Debbarma. He received the BE degree in electrical engineering from NIT Agartala in the year 2009 and MTech and PhD degree from NIT Silchar in the year 2011 and 2016 respectively. He is currently an associate professor with the Electrical Engineering Department, NIT Meghalaya, and leading the department as the head of department. And his research interest broadly include power system and smart grid. And he was the organizing chair of second 2018 International Conference on Energy, Power and Environment, co-sponsored by IEEE Kolkata section, held during 1 to June 2018 at Shillong, and he is the program chair of the 4th 2022 International Conference on Energy, Power and Environment, technically co-sponsored by IEEE Kolkata section, IEEE Guwahati subsection and IEEE IAS, and he has also completed several sponsored research and consultancy projects founded by Department of Science and Technology, Government of India. By this, I would like to call Professor Sanjay Debbarma to deliver your talk. Thank you, sir.
Thank you so much for this brief introduction. So I think I should share my screen right now. Yeah, please let me know if screen is visible to all.
Yes, sir, it is visible.
It is visible, right? Okay. Can you see my slides?
Yes, sir.
All right. So let us start then. Good afternoon to one and all the faculty members, dear participants, students, the organizing chair of this event. I'm grateful that I've been invited as one of the speakers for this workshop. And today I'll be delivering an interesting topic which covers the energy trading from one peer to another peer in a distribution network, which is now becoming active due to the penetration of more and more distributed energy resources. So let us begin with that. To start with, normally I always prefer discussing on the conventional system and gradually goes towards the recent trends. So if you see the legacy power system, which is the conventional grid, how they used to operate. There used to be a generating stations, transmission networks, and then low voltage side, which is nothing but a distribution system. Normally, we generate at around 11 kV. It is being transmitted at different high voltage levels depending upon the tie lines and their capacity, and then it is being distributed among the customers. Customers can be of various types. It can be a transportational customers, it can be an industrial customers, it can be an agricultural, and so on. So depending upon that, the voltage level depends. Now here, if you see how our system is currently, our power system is currently operating. Basically, our legacy power system, it holds certain features. Now, our power system has never thought of that it will operate in a very complex manner, where we never thought of that someday we'll be penetrating renewables at the distribution network medium voltages and at low voltages. But then, as we are going towards green energy, and as the objective of smart grid, one of the objective I'll rather say is to mitigate or minimize the greenhouse emissions. We have to encourage more and more green energy to be penetrated. Now, if you see in this context whether our grid currently is operating in a smart way or not. So what is mean by that? If you say whether there is a two-way communication, because earlier utility people used to contact us, but if customer can also give their data information through a certain platform to the utility, there we can say that we have achieved two-way communication. So the question is here, how to communicate in a bidirectional way? The simple solution is replace the traditional meters with the smart meters. The sensors will allow you to exchange the data, right? Now, this is from the grid point of view. Now, from a customer's perspective, if you see that today we can handle our banking at uh, at any edges, like we can use mobile, we can use computers, then we can easily get a clear picture of our monthly statement in a of the bank. Similarly, if we can manage the similar way the electricity consumption, then we can certainly see our peak demand, our peak demand or maximum demand, our consumption, whether we are exceeding 100 kilowatt hour, or like how much the bill varies, because certainly we know that in India we follows block meter tariff. So if you see every 100 kilowatt hour, you'll find that there's a change in uh, electricity prices, right? So obviously, if you can have this view, then you can avoid power consumption, especially during peak hour, where you can save your money, right? So this is what the advantages we are going to have when our grid will act smarter, right? So two-way communication is very important. Though we have in some states in India, we have implemented the smart meters, but then the path is very long. So conceptually, if you see, a smart grid not only talks about penetration of renewables, but also information exchange. The information may be in the form of price signal. The information exchange may be in the form of kilowatt that you generate, kilowatt hour that you consume, and so on. So according to European technology, if you see that they define a smart grid as intelligent network that integrate the actions of all participants. It may be generators, it may be consumer, or both, so that you can deliver the electricity in a very economical way and at a secure in a secure way, with the reliability, right? So that's very important here. So earlier, our power system used to say that let us build a big power plant because it used to be a cost saving part. But now we don't only talk about the big plants, but also we talk about the small generators. Small generators earlier could not find their, platform in the electricity market, but now we encourage more and more small generators, PV, like wind, and we also have batteries to be penetrated to the grid, right? This way, we are utilizing the grid assets, right? We are utilizing the grid assets in a very optimal way. That means you have a batteries. Why to power only your house? You can sell any extra generation that can be stored, and you can sell it through batteries. So there are so many private players coming up in the market, like maybe I can say Tata, maybe I can say some of the distribution companies of the state. Maybe they will be featuring their way to to supply ancillary services at the distribution level as well. Now moving forward, when you talk about penetrations of more and more distributed energy resources, we also talk about electric vehicles. The owner of electric vehicles will be called as a prosumer, as you all know, because EV can supply power whenever there's a requirement because they have an onboard battery. And also, if your EV is getting charged from a PV, that means it is a load, right? So it acts as a prosumer. Now, if a decent uh, mm, platform is being given where you can charge as well as discharge your batteries, right, at you near to your home or your localities, you can light up your loads, right, and during emergencies, and at the same time you can earn revenue, right, in the form of discounts in your bill, right. So this is how the European market and the market in US, they are going to be transformed. I'll also talk about Indian context maybe in the subsequent slides. So the architecture, if you see all in all, we have a generation, we have a transmission, and we have a distribution. So massive transformation that has been held is here in the distribution network. So our distribution network was earlier passive, okay, and power was flowing from uh, network to the loads. But now it has become, you know, active. So active distribution network is nothing but penetration of more and more renewables, DERs, batteries, microgrids, e-waste, and we have to, you have to go for a load flow so that we can find the congestion and the power losses. And therefore, in active distribution network, you'll find that the role of distribution system operator is very important, and it will be called as a new entity. So new entity, DSO, which we call very commonly in Europe and as well as in US, they are having this important role. So you'll find that DSO will be actively managing the network access limits of the active customers. So it will be possible by calculating the operating envelopes. Here, the operating envelopes means that you are you are limiting the uh, participations, the physical limit of each customers, I will say rather, uh, in the point of connection to the grid, right? So all customers who are a part of the electricity system in future at the distribution level, they will have a operating envelope, and this is the physical limit of each customer's point. For example, if you have a 100 ampere fuse at your home, most of us we have circuit breakers. So you'll find that if you draw more than 100 amperes, your fuse will just kicks in and it will protect the systems, right? So here upper limit is what I'll say the operating envelopes. So that's very important, and it will be decided by the DSO. Now, as I said, active distribution network, so you'll find that there will be lots of sensors employed, because if you don't have any sensors, how do you visualize the entire network, right? So there will be CTs, PTs, PMU, and other microprocessor based devices in the substations, and they will give you entire picture of current, voltage, frequency, and then kilowatt hour consumption, kilowatt generation, everything. And thereby you can decide whether the power flow at the distribution system can be managed optimally or not, while ensuring the grid limitations. You should not violate the grid constraints. The network constraints may be the feeder limits, transformer limits, etc., etc., right? So the smart distribution network, if you say, it will be a two-way communication, fully digital, more and more penetration of distributed energy resources. Keep in mind there's a difference between RES and DER penetration. When I say renewable energy resources, you know, it can be a part of DER, but DER means your generators are locally, dispersed in nature. It is not in a one place, but it is distributed locally in entire geographical area, and therefore DER is a suitable term which most of the engineers they use while representing distribution network. We have a more and more sensors deployment, because sensors are important. IoT devices are important here, right? Aggregator, in the sense, when you have so many DER which are dispersed in location in various places, you find that they are geographically dispersed. Aggregator will aggregate them and take this aggregated power to the DSO, right? So DSO will manage those flows, the power flows. So role of aggregator is very important because they have to manage the assets of the grid. Then you'll find that as you have to handle the aggregators, there will be emergence of DSO and distributed market operator. Now, it is important to know what is the difference between DSO and DMO. You'll find that DSO is actually comes under this. I mean, the aggregator comes under the DSO. I'll say rather, and here the participation is managed by the operator, whereas the market operator, which is distribution market operator, their intention is only to clear the local markets and carry out any financial settlements in case if it is there. Okay, so market settlements is different, and operation and control and security issues managing and the distribution network is different. So as we talk about more and more DER, we are giving rise to prosumers, because a building having a rooftop panel, they will be called as a prosumers, where you'll find that they can sell the electricity through net metering with the help of smart meters to the grid, for which they will be compensated. And also you'll find that the moment the prosumers grows at the distribution level, there will be so many market players. So every building will be one market players. They will be aggregated by the aggregator and they can take part in a grid. This way, you are creating a new platform for revenue business. So you can collect money. You can have a platforms which will not only give you a new business platform, but also it will help you to build up a new job or business for the local peoples around. Therefore, the role of prosumer is going to be very important, especially at the distribution network, of which electric vehicle will play a major role. EP is a load when it is charging. Please keep in mind. But when it is discharging, that means you need to have a vehicle to create infrastructure. Now, if you see, an electric vehicle can discharge their power only when they get a signals from the grid. Okay, that means minimum there will be two outlets or inlets, I will say. So connections will be there. So one is for charging, one is for discharging. To discharge, you need a common points that will be given by the charging stations or the aggregator, I will rather say. Now, to initiate vehicle to grid operation, you must know that you should have a charger, right? So there are only limited chargers. For example, Shedemo, which is a Japanese charger. So these protocols will help you to have vehicle to grid. Whereas if you see combined charging systems like CSS or CCS, I will rather say, they also provide, maybe not now, maybe after 3 to 4 years, they will also provide you the provision of vehicle to grid. So not all the chargers are supporting vehicle to grid in the market today. You may have a Nissan Leaf car, you might have a Chevrolet, but to have V2G, you must have Shedemo, because this Shedemo, it supports vehicle to grid in the current market. But by 2025, we're expecting that CCS, whether it's a European or whether it's a US protocol, they will be on the market very soon. So the benefits, if you see, of having vehicle to grid is they can mitigate the grid overloading, because ultimately when you charge, you'll find that your charging stations are connected to the local networks, right? If it is not PV photovoltaic, integrated, that time one can help mitigate the overloading the grid by charging and discharging process. But this charging and discharging process has to be very much coordinated way, right? So this way, one can generate revenues from the consumer's perspective. At the same time, you are not buying batteries separately, whether you are using the same batteries which is on board in the electric vehicles. So there you can have a cheaper energy storages because you're not investing. Now, to discharge, you are discharging to the existing network. existing distribution grid, right? That means you are not making a separate dedicated network, which says that you are making use of existing resources, right? Then you are contributing to the environmental impacts, which will reduces ultimately when you are producing power or supplying power at the local level. You are not depending on the certainly on the conventional plant which is situated far, so they might not have to generate electricity at that period of time to support the peak load. So therefore smart charging is very important. Just merely having EV and randomly charging will not help. It must be supported by a proper charging discharging framework. All right. Now, many of the countries they are already they have completed their pilot project on how to supply the power so that at peak hours, so that the frequency of the grid can be regulated. Right. So as I said, so if you want to support V2G, you must have the CDMA charger, and the charger should be supported by the algorithms, and there must be some communication systems because it will help to exchange the information between the vehicles and the charging stations. For example, state of charge of the batteries, for example, what is the next driving time, what is the maximum and minimum SOC levels that require to be maintained, right? Those are the constraints that must be considered when you implement the charging algorithm, right? So as I said earlier, that you have these so many protocols available in the market, CHAdeMO being supported by most of the vehicles, and they also support V2G as well as V1G, right? Now, just merely aggregating and integrating the prosumers or DERs into the grid will have a serious impact in the grid frequency response. For example, if you see this particular figure, which is belonging to the Great Britain, if you see that whenever there is a continuous service events, it is within the limits because this service events is very common. That means there may be a supply and demand mismatch. But then when there's a major, you know, uncertainties, which is nothing but, for example, here the loss of 133020 megawatt power or generating unit has been shut down suddenly, see the rate of change of fall of frequency. This rock off is very fast. But then when the rock off falls, you'll find that they reaches here to this to this particular point because it was initially supported by its inertia, which is normally up to 5 to 8 seconds. And after this inertia has become zero, which is the kinetic energy stored in a rotating machine, you'll find that the primary frequency controls, it regulates, and it start contributing to the grid through your primary governor response. So the set point will be updated, and accordingly you'll find that the response goes towards the limits. Say if it is 50 hertz, if you take plus minus 0.05, so primary helps up to 30 seconds. Then the moment primary has done its jobs, but still there will be a steady state error. To mitigate the steady state error, AGC has to come into account, where the main intention is to update the set point of the governor, which is always you'll find in all the power systems of the world that this set point is being updated every 4 to 5 seconds, right? So this is how the frequency of the grid can be maintained, right? But then if under this condition, if I penetrate more and more DER, where they have a random generations, at the same time the load keeps on varying, right? So this fall of rate of change of fall of frequency will be very faster. This rock off is fast means it will fall faster. The moment it falls faster, you'll find that it might trip the under frequency relays. So as a result, there will be load shedding, which we have to generally avoid, right? Load shedding is the last stage, or you can say the last resort that we should go for. Otherwise, we should be depending upon the reserve that is available in the regulation market. So vehicle to grid also supports, as I said, the frequency control structure. So if you see this is an power system, you'll find that PB, that is plug-in electric vehicles, can be interconnected, and transmission system operator can give the power signal here so that extra power which is required to the participation factor can be you know, produced and given to the grid to support only during this peak hour. Okay, provided sufficient reserve must be available with the EV aggregator. So this is one aggregated EV model of mathematical model you can say that supports vehicle to grid. Now, as you know, that more and more electric vehicles will penetrate with a smart charging and discharging framework, they can improve the frequency response as you can see here. Okay, the dotted line. And it was taken from one of the author who published the paper in the year 2015. This is by Dr. Ijakast. And this response shows that you may have a different secondary controller, but then you can always keep the responses, uh, frequency response. You can make it within the git constraints. So whether you use any controller, PI, PID, whatever, you can regulate this so that the steady state error can be minimized to zero. This is one of the some of the results, as you can see here, where the power produced by the electric vehicles, which is very fast, as you can see, whereas the power supported by the hydro has a bit time delay due to operations of its operation constraints, where they will again generate power. So the power contribution from EV is lesser, whereas the power contribution from your conventional plant, which is a big hydro in this case, is more, right? So all in all, they are mitigating the grid uncertainties. Similarly, the thermal results are shown in the next figure. Now, moving forward, as I said, more and more DERs will be available. For example, rooftop panels, EVs, batteries, and the smart loads, right? So they are going to play a very important role at the distribution network, making the distribution network very active. Now, let us see the transformation that has been in the power system sector. In 1990s, we talked about deregulation. Deregulation, as you all know, is nothing but it is the separation of power producers from the transmission and distribution company. They were forming a IPP, independent power producer, and they are like competing themselves in the electricity market, right? So at generation levels, there is a huge competition nowadays. If you see Tata, if you see Reliance, if you see state-based government generators, if you see NTPCs, NSPCs, so many power producers are there nowadays. After deregulation, we started talking about the customers. Earlier, we had no choices. No, in US, if you see, customers are not even given a choice to buy electricity from where they want to buy. That time they used to call as a rate payers, but now they are called as a customers because they have an option to choose from whom they want to take electricity, right? Similarly, deregulation has been done in airline sectors, also if you see our communication sectors, also we have so much market players like Reliance Geo, Airtel, BSL. So many players are involved. Similarly, from deregulation to customers, and now in 2010s, after one decade from 2020s, we are like nowadays talk about more and more penetration of IoT devices, sensors, and DERs. See the transformation here from deregulation to customers to your IoT. This transformation is because we have seen that most of the people, especially in US, they have shown their interest. As I mentioned earlier, that DER is increasing at a very faster rate at the distribution level. Why? Because the people want to participate in the electricity network. Okay, so it is their wish, and not only the wish, when the technology and the demand meets, the solution comes. So here the technology, if we have, then you will certainly find that the price of the solar panels, the batteries will be very competitive in the market, and due to this competition, the cost will reduce, right? So we talked about centralized production, the big power plants where the electricity flows from one direction to another direction. Maybe I can say unidirectional. Today we talk about increasing number of EVs and more integration of small generators. But in future we'll talk about peer-to-peer trading between the microgrids, within the microgrids, between the neighborhoods as well, right? And at the same time, you'll find that customers having PV panels will be benefited more because they ultimately you'll find that when they sell electricity through net metering, you'll find that their electricity bill overall will be lesser. Okay, and also the prices will reflect the availability of the renewable energy. If you see the price of renewables are more or less same, competitive, I will say rather with the traditional generation. But in future, you'll find that if you have to consume green energy, maybe market operator will give incentive to the uh, sellers because they will be selling locally generated electricity wherein they are selling this electricity in the nearby areas, mitigating the transportation losses. So their electricity prices will be different than the conventional generators. So if you see the traditional electricity flow, this is the conventional system where it is going. There's a competition between the bulk generating stations at the wholesale market because all they compete at the wholesale market at a high voltage. Maybe I will say that most of the central government based stations in India and state government based generating stations, private players, they bid their uh, uh, power and and do transactions in the wholesale market, maybe at the real time, maybe at the day ahead, maybe bilaterally, right? But when we see that more and more shifting towards the involvement of prosumers in the distribution network is because, as I said, that 69% of the US population has agreed to be the part of the marketplace, energy marketplace. That means they want to sell electricity. They want to invest on the rooftop panels, and after investing on the rooftop panels, they want to sell electricity to the grid to do a business, right? So when you find that the people of the US they are interested to be a part of this marketplace, and at the same time you'll find that here the solar installation has been increased. Okay, so this shows that technology and the demand they must meet. Okay, next if you see the record of the European countries from 2000 2022, you'll find that there's a huge drastically installation of these renewables. Okay, in a transmission and the distribution level in terms of gigawatt. So it shows that more and more penetration of renewables is very likely in the near future. Now let us see one case study where in California you can see in 2008 there's no red dots. Here the red dots shows the PV penetration. Gradually in 2014 you can see this brown or reddish, you can see it is being seen, which means there's a photovoltaic penetration. Gradually in 2020 again you see, and now in 2025 it's expecting. So if you'll find that more and more renewables are getting penetrated in California. Now that means during daytime you can generate more and more solar energy, right? That means during daytime you'll have a absolutely very nice huge generation, and you can sell this power to the grid. Now what is the issue? Now the issue is that if every person is becoming a prosumer, every buildings is becoming a prosumer, then by installing the rooftop panels, then what will happen? Then during peak hour, you will find that they are generating very huge amount of electricity. Now you will be happy that this is fine because we are generating free of cost, right? We have invested money on my solar rooftop panels. So it's good that we must generate and we must consume, but think about the load curve. So this is one typical load curve of California from 2015 to 2023, where this is known as duck curve. This duck curve shows that this profile from morning 12 a.m. to 9 a.m., more or less you'll find that this demand is more or less fixed. But then when the moment you goes towards 12 p.m. noon, this demand is falling. Why this demand is falling? Because everyone is generating their own power at the rooftop panel that they are consuming. So this is for a grid. So now grid operator will think, well, I have a thermal generators connected to the grid, I have a hydro, I have a nuclear. Now right now, if everyone start consuming their own power to renewables, then you'll find that they are overall they are mitigating, I mean, not mitigating, they are fulfilling their demand. But what about the grid has a big players who generate electricity. So suddenly they have their plants, and there is no requirement for the power to be delivered. Now think about their condition, right? So demand will keep on falling. See, it almost becomes zero here, in the sense that now generation is more than the consumption here, and this is likely to fall more. So this takes the shape of duck belly, right? So this is duck curve, and duck curve is a concern because during daytime, when you have a very huge power production through renewables, that time your demand is lesser, right? Then what will do with your power generation, right? So therefore, again, one more concern is that after 3 p.m. you'll see there's an exponential rise, in your demand. So if I shut down my generators, say for example, right? If I shut down my generators like thermal, because thermal generator again to restart it will take at least 8 to 10 hours. So you see the rapid shoot up, right? So this is a concern. So effective policies is required here. The control operation has to be very, optimal, so that you can meet this peak demand during the evening peak or evening time. At the same time, you should manage this duck belly. So this is a concern not only seen in California but also in Germany. So there must be a method, to to see how this excess electricity generation can be sold somewhere, instead of, because there's no demand, then let us sell it somewhere. So for which you need to have certain platform, right? So I will be talking about this platform maybe in our upcoming slides. Now, if you see this particular diagram here, you see that this is the load, which is cyclic in nature. The blue line, which is cyclic in nature, is a load, right? As it has been mentioned here. So this load is cyclic. See, this is Monday, this is Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. If you see, the load behavior is cyclic. So it is same every day, right? So any power utility people can easily guess, right? That next day also I am going to get two peak. One day there's two peak. See, one peak and second peak, the first peak and the second peak. So every day you are getting the same peak, which is more or less same. Now, now you say that now I have penetrated renewables, say wind, okay? And this green color shows the wind generation. Wind generation is very uncertain in nature. Whenever you have a wind speed, you are generating. If there's no wind speed, you are stopping, you are stalling your generation. Then again, it is increasing. And it is not cyclic. See, someday you are less, someday you are more, again less, again more. So you cannot predict. You have to forecast, right? Earlier, forecasting of load was easy, right? But now, forecasting, if you talk about forecasting of wind, it's not so easy, right? Maybe for short term you can predict, but for a long time it's very difficult, right? Now this blue color, what you see here, is the net load. That means if you assume this wind as a negative load, the difference between two is this blue one. You see? So here, this is the net load. Now the net load, if you see the blue line, it is not cyclic. Sometimes it is falling here more, Sometimes here flowing is even more. Even here is so, huge. So prediction has become very difficult. So therefore, we have to apply here AI/ML technique to accurately, observe or find out the net load when more and more distributed energy resources or renewable energy sources are penetrated to the grid. All right. These are the challenges. So the new paradigm will say that let's have more and more renewables, variable generation, which is, and then big power plants, because 70% of the generation in the world is based on the conventional generation, dominated by the thermal systems, and then demand side resources, which is nothing but your distribution networks, low voltage assets, I will say, okay, because it has UVs, rooftop panels, smart loads, all are, of low voltage. So this is the new paradigm. Now, under this paradigm, how do you, make the role of prosumer very active? Okay, so let us have an community here. There are two microgrids, one and two, and they are interacting with each other, and it is forming a community. So here we are talking about the distribution network, where you have a commercial building, hospitals, residential area, wind farm, UVs, rooftop panels with the buildings, and so on, right? Similarly, there's one more microgrid. If they can interact each other, then it's very likely that they can help each other whenever there is a necessity, depending upon the grid constraints. So this kind of community microgrid actually is exist in a real world. I'll show you the example in upcoming slides, how the two microgrids can be interacted and their performance can be improved. Now, the moment we interact two microgrids forming a community, you are creating a platform. What kind of platform you talk about here? Let us see. The platform says that if you build a platform, like as an aggregator, you are creating a business platform, right? You are an aggregator, so you are a broker. Now, what is your job is to aggregate all the DERs, all the microgrids nearby. Then you help them manage the business, and due to this you can earn revenue here. So it is giving a new platform. Okay, this platform will help you to you know earn revenue. Now, if you talk about the customer engagement, right? So earlier customer used to be passive, but now they become active with more and more penetration of smart meters in the networks, and thereby you are engaging yourself and participating in the grid. So you'll be called as a prosumer. Location based pricing is very important, which I'll talk about this in the next slide, because everywhere the prices are not same, right? In all the nodes, in all the substations, price is not same. It depends on the amount of energy which has been traded. Then it depends on the congestion that you have, congestion in the network, and it also depends on the losses, because transportation and losses of energy is always important, which must be considered. Ancillary services, in the sense that the moment you have a small generators, batteries, they can provide emergency services to the grid whenever they need, and they can build a business. The most profitable business, ancillary services, is considered to be a most profitable business here, because ancillary services will manages the voltage at a distribution and transmission level, as well as it also manages the frequency, right? Grid frequency. So when you provide any frequency control services or voltage control services, that's a very important emergency services it considered to be, and it is a very profit making business. Hyperlocal demand response is nothing but like different types of assets you have or resources you have. So out of this, what you want, whether you want to shut down the inverters, whether you want to get power from the generators, whether you want to go for so many options will be there, and they have the corresponding prices. So based on the price signal, an operator will make a suitable choice. Okay, that's a hyper local demand response, and I'm going to talk about this in the upcoming slides. Billing is very important because you have to settle the bills. So billing and settling is through blockchain, which I'm going to discuss in an upcoming slide as well. Now moving towards the concept of transactive energy market. Why? From where it came? See, when I talked about the previous power system model, you might have heard about demand response. What is demand response or demand side management? You'll find that in the utility, in the distribution network, low voltage side, customers has a loads, and the loads are of several types. So if you want to categorize this load, let us categorize as a essential load and non-essential load. Essential load is something which is very important for a house, like lights, fan, right? Non-essential load is HVAC loads, heating, ventilation, and air conditioning, right? So you might have a air conditioner at your home, you might have a centralized heating system, okay, so on. So those are luxury, so it considered to be a non-essential load. Now smart meter can be connected to this essential and non-essential load, and if you allow the utility to control this non-essential load when there's a peak hours, right? So your electricity bill will be lesser, and at the same time the stress on the grid will be lesser, right? And as the loads is being shut down, you don't have to generate power from the conventional plant, thereby contributing to the greenhouse emissions mitigation, right? But the issue in the demand response is that the privacy will be compromised, right? It is very important. The privacy is a very important, like in most of the developed countries, why they have not customers are not participating mostly effectively in demand response is this. Privacy is a very huge issue. But transactive energy market, it doesn't only talk about the demand response, that is the participation of uh, loads. It also talks about DER. Okay, so demand response only controls the loads, but transactive energy market framework controls the load as well as the DER that is penetrated at the distribution level. Okay, now let us understand from this fact the key features here. It allows distributed decision making. Okay, that means when you have a locality, this is say your locality, and you have a more and more DER penetrated, right? And you are controlled and observed by this distribution system operator. So this is a local market, I will say, and this local market is managed by distribution system operator. When you see the transmission system operator, it manages the big plants, big industries, right? So TSO and DSO interaction is very important here. Okay. So normally TSO and DSO interaction, why it is important? It is important for different reasons. Okay. For example, if you want to talk about grid stability and reliability, right? So you have to TSO and DSO have to work together to ensure stability and reliability of the entire power grid. That time coordinations, managing the power flow is very important, which eventually help in preventing the blackouts. Okay. TSO DSO interaction will also help, efficient integration of renewable energy sources at the both transmission at the distribution level. Okay. Also, you'll find that you are utilizing the demand response as well as the flexibility services which is available in the grid. And here the participants will be the network assets, which is the air, batteries, prosumers, EVs, etc. Okay. Now, here talking about transactive energy market, the most challenging thing is your calculation of distributed locational marginal price. Now, what is this location or locational marginal price? Let us see. A locational marginal price is the price, you can say, okay, which is found at each load zone. So a substation might represent several load zones here. It might be at the external interference with the neighboring control areas, or it may be the hub. Hub is nothing but this collection of locations here. That means, in a very simple word, locational marginal price is a method, pricing is a method to determine the cost of electricity delivery. So different places will have a different price of electricity. Why? As I said, it is consist of three components. the amount of energy. So amount of energy is not same in all the places. It depends. Okay. The congestion cost, right? Congestion cost is nothing but the cost constraints due to the limitation of the transmission line. All right. And the losses. If you are transactive energy in a very shorter distance, losses will be lesser. If distance are more, the losses will be more. So LMP are calculated at each substation or at local load zone every 5 minutes, and it is being updated. Okay. Now let us see how this LMP can help. As I said, LMP consists of three components. One is energy cost. Energy cost, how much you are about to transact, that amount will reflect the price. Okay. Congestion cost is what? Suppose this is a big building, okay, and this big building has 100 megawatt of the requirement, right? Now you need 100 megawatt. You have two options. This is one option. This is another option. These options talk about your big power plants, but it is far away from the load center. Now this is very cheaper because it's a big power plant, so it can produce at $10 per megawatt hour. Here, this generator is expensive because it is not a big power plant, but maybe it is a power plant having a combination of diesels and hydro. So you'll find that it is also very much, near to the load center. This is far away and this is near. And the cost of this power plant is more, for example, which is $20 per megawatt hour or megawatt per hour. Okay. Now here, the concern is this is a transmission line through which your electricity has to flow, right? Now, if you have a transmission capacity constraint of 50 megawatt, whatever may be the capacity, but you can only transfer 50 megawatt, and your requirement is 100 megawatt. So out of 100 megawatt, you are bound to take only 50 megawatt from this. That means you are paying cheaper price, whereas this there's no limit in the line transmission line, and you can take also 50 megawatt. So all in all is 100. So you can see the price difference. That's signifies here the congestion. So the price here was $20, here $10. So difference is $10 here. Okay, that's the congestion cost. Okay, so congestion depends on the line constraints. Similarly, the marginal losses is nothing but the losses. See, if you are transferring your power from large distances, you have a more marginal losses, less losses for a shorter distance. So all these costs are wind up and it forms LMP, locational marginal price. LMP is very important here. Now, why DLMP? So what will be the difference between, see, LMP is for a wholesale market, for a conventional system. Now, when we talk about more and more renewables in a transactive energy market or in a market having a microgrids and a distribution level, at that time, locational marginal price will be called as distributed locational marginal price, which is called DLMP. Okay, DLMP. So DLMP is an extension of the traditional LMP, I will rather say, but they considers not only the energy amount, not only the congestion components, not only the losses components, but also the contribution and complexity due to distributed energy resources. Okay, that's very important here. And here you'll find that the moment we talk about LMP, you'll find that you have to consider the capabilities of DER, because DER is not same everywhere. Somewhere it is PV, somewhere it is wind, somewhere it's batteries. Okay, and it varies from different geographical area to other areas, right? So designing or implementing a characteristics of a different DER is very complex, and therefore calculation is very difficult. Okay, the challenges here is calculation of DLMP because of diverse, variation in the DER characteristics. All right, that's very important. So maybe if you can calculate DLMP precisely, then by assuming the characteristics of a DER, then what happen is you can accurately, perform. You can accurately perform many services. For example, if you can calculate DLMP nicely and very accurately, you can encourage its efficient use of the DER. That means where to integrate DER, that optimal placement will be clear to you. At the same time, you'll find more accurate price signals because of the consideration of characteristics. Rather, I say that this is very difficult, but once you can crack this, it's very accurate for you to manage the optimal power system here. Next is incentivizing DER participants. That means if you can have a DLMP calculation accurately, then you can incentivize the DER owners because they are offering several services like ancillary services like demand response, frequency regulations, voltage regulations, etc., etc. Okay, as I said, challenges are here to calculate DER, DLMP, because of the behavior and impact of numerous DER because they are diverse. Their behaviors are diverse. Okay, some are static, some are rotating. So exactly monitoring and the characteristics and defining is very difficult. On the top of that, we have to reformulate the market regulations here. That's very important because the conventional maybe framework what we have currently might not be suitable for a system where you have more and more renewables penetration. All right, so here the policymakers has to play a very important role. Therefore, to get a advantage, the European countries and many US states, they have came up with the concept of transactive energy market. So here transactive energy market use a parameters which is called value. This value is a term or key operational parameters, I will say rather, which represents the price signals and incentives, right? So this value is very important because every devices that you have in the power system at the local level, maybe DER, maybe your batteries or whatever, they have certain value. If you can transact this value, right, then you can optimally, play a very important role in the electricity market. So transactive energy market is a platform where it will support the creation of local energy market. It will help the interaction, it will help to grow the interaction between DSO and TSO. And at the same time, you'll find that they will be considering the loads as a participant as well as the generating unit as a participant in the markets. So this is a typical transactive energy framework where you have a residential participants, then you have a microgrids, then you have a local grids, and you have a regional grids. And it has been interaction being managed between TSO and DSO, right? So the power flow plays a very important role here because power has to flow from one end to other end, provided the constraints must be respect. The respect must be there for the constraints, like we must not, access the transmission, the feeder limits, the transformer limits, and so and so. So microgrid is very important, therefore, because microgrid is something which is a block building block of the smart grid here. I'll rather say because microgrid has a critical infrastructures which must be managed, and at the same time your microgrid will act independently and it can be also operated when it is online with the grid. So microgrids has a prosumers. When this microgrid has a prosumers, they can perform peer-to-peer transactions. At the same time, this microgrid can also have a interaction with other microgrid, thereby forming a community platform, community microgrid platform. So therefore, if we if we have a TE system, what will be the benefits? We will be having increased penetration of DER, which everyone knows, better utilization of grid assets, which makes TE system different than the conventional systems. Here, assets means the DER and its value that you have, okay, and also participation of the consumers in the market. The new opportunity for energy trading as you are giving rise to a local market. Local market regulations and other policies has been set up in different European countries, and they are already in their pilot project, right? So if you see the benefits what we have, if we have a transactive energy systems, then we can say that not only we can utilize the local energies available at the bottom level of the distribution network, But then we can also sell this electricity after being consumed. The excess amount of energy can be sold in a grid through DSO and TSO interaction. That's very important. And here the forward market will be the platform where the buy and sell can take place. The forward market is nothing but day ahead market, and the spot market is also known as real time market. So anyone can buy and sell their excess generations, or they can have a contract in a day ahead, and they can transact their energy, and they can perform a business here. And what is important in the market? The importance is the amount of energy and the corresponding price, which must be sealed, and the bid must be placed before the competent authority so that they can uh, settle the market later. Transportation is very important because the transportation and enter the energy will be transported to the uh, network. So network pricing is very important here. In India, we call network pricing as a wheeling charge. Okay, that means continuously power will flow, for which you have to pay because you are taking that particular distribution wires or transmission wire on lease, because you have to pay the charges, right? We pay charges for plying our vehicles on the road. Similarly, when you are using the infrastructure, you have to pay for it. So transportation cost is very important here, and which is known as wheeling charge. So as we have understood that the participants are the generators, the networks, because they own the networks like transmission and distribution wires, and the role of consumers is going to be very important. And definitely, if there is no regulations, then I can say that the market might not be efficient, and market might not be transparent. So government has to be involved here. So let us see the case study. So one of the objective of having a transactive energy market is creation of a local market. And in the local market, one can have a peer-to-peer transaction. So one can have a peer-to-peer transaction between a big plant and a commercial building. At the same time, you can also, have a bid and ownership with the prosumers and consumers. And there must be tech platform. Tech platform is nothing but you can say cloud through which you will exchange the data and perform the business. Well, next case study, what I'll talk about is the locationalized demand response, which is very important here because a substation will be there, and he and she, the operator, he and she has to, make decision. If the substation is on the verge of overloading, what option they must choose? Whether they should turn off the AC for this particular value, which is 50 per kilowatt hour, 0.50, and or commercial buildings where they will turn off the lights for this much amount of the electricity value, or conventional plant which will deliver power at this value. So a substation has to make a wise choice, so DSO will be making her choice. So this is DSO who will make this, choice which one they should prefer. So accordingly, incentivize will be there for the participating, participants or participating generators or the loads or the buildings. Now, I talked about locational based pricing earlier. LMP is locationalized marginal price. Now you see how this price is important, because here we have a prosumer selling power to consumer, and here's two aspects. Somewhere there is a prosumer and consumer, they are doing transaction, but there is no substation in between. But then prosumer and consumer is doing transaction, but there is a substation in between. The question is which one we must prefer. We must prefer this particular, the first option, because here there is no substation. That means the distance cover will be lesser, and hence transportation losses or the losses in the components will be lesser. So overall electricity price will be less. So therefore, in peer-to-peer transaction or peer-to-peer trading, we encourage neighborhood transactions rather than, node to node transaction or substation to substation transactions. Now, one example of this peer-to-peer you can see in Illinois Institute of Technology, Chicago. So, entire university has been, consist of several years batteries, they have diesel generators, they have photovoltaic. And this university is an example that yes, a microgrid plays a very important role, and they can survive any contingencies which might lead to cascading event, thereby reaching to blackout. So this microgrid is very important, and they can survive when there's an issue in the grid by isolating themselves. So the microgrid at IIT Chicago, which is in Illinois, so they have shown that if I can make my building a prosumer, there are so many buildings, and so many buildings has a rooftop panels. You can see here photovoltaic panels. They have a gas turbine. They have a batteries here. They have a EV charging stations, and this is the utility grid, and this is the point of common coupling. And there are two feeders coming out. This voltage is a US standard, so it may not be same as Indian system. But then you can see here the concept that they have isolators, they have circuit breakers, and the system is very robust here. Now let us see how it performs. For example, if you take in one building here, okay, in this building they have a rooftop panels, and the first floor is your DC subsystem, and the second floor is the AC subsystem. Okay, now that means in the first floor they have a DC load, so they are generating in the rooftop panel PV in the form of DC, and they are consuming, and then excess power they are bringing it to the AC bus through AC to DC converter. Similarly, a PV array is installed. As I said, it can also can be connected to the ground floor, where DC to AC inverter can be used, and rest can be sold to the different other buildings within the microgrid. And here Illinois University itself is a microgrid, right? So that means you can see here that one building has a AC and DC loads. See, this is DC loads, all LED loads, and this is your AC loads at the ground floor. So you can you can see that how the entire system can operate if you form a microgrid. So maybe your institute and Aukala has I believe that renewable penetrations. It can act as a microgrid, provided they have all the protection switchgear components, and SCADA, and they should operate very optimally. Now, one more interesting figure I would like to show here is that this is the IIT Chicago microgrid. Just now I shown, right? In IIT Chicago microgrid, the interestingly how much they are producing is very important here. So they are producing around 12 megawatt, okay? And the grid, which is the blue color, is a Bronze Valley microgrid of the particular city. So these two microgrid are forming a community microgrid, right? So the red one shows you IIT Chicago are generating 12 megawatt, and they are generating 11 megawatt. All in all, if you see their megawatt values, right? So it can be sum up, and they both can help each other whenever there's a any contingency occurs. So you can see here that when your IIT Chicago microgrid independently operates, they have a stability issue. But the moment there's a coordinate operation, most of the poles are in the left side of the S-plane, which says that this is a root locus diagram. It says that the stability can be maintained in the microgrid if they are operated in a coordinated fashion. Okay. Therefore, peer-to-peer trading is getting importance nowadays, right? And it's very important that we must know the benefits. The benefits is you're transporting your energy, so you don't have to pay transportation price. I mean, transportation charges will be lesser. At the same time, you are creating a new business platform, and you are motivating or encouraging the populations to penetrate renewables at the rooftop and take part. Now, this is possible only when you have a technology. So what technology we are talking about here? We talk about here the blockchain. So what is blockchain? We all know. So blockchain is nothing but it's a ledger, it's a distributed ledger, okay, which is just a part of the bill settlement. For example, why blockchain is required? See, there are so many prosumers, same hundred or thousands of prosumers are there, And also, there are so many consumers. Everyone is transacting with everyone. I am transacting with so many peoples in a one day. Say for a 1 hour I'll sell power to X, for a 1 hour I'll sell power to Y, for a half an hour I will get power from someone else. So if you see, there will be so much contracts. These contracts cannot be manually settled. So there must be some efficient billing settlement process, and blockchain is supposed to be the technology because it is very secure, transparent. It has a smart contract which settles the transactions automatically and settles the bill immediately, right? So blockchain technology is very important, therefore, and plays a very important role in our system. And maybe in very very soon, in India we have only 3 pilot project right now. Maybe more and more we will see, and there will be in a full-fledged commercial platforms for P2P. Maybe I'll discuss this point in our subsequent slides. Here, the blockchains, what are the features? It talks about secure. Why secure? Because anytime you want to add information, it has to be approved by majority of the users, okay, through the computers. And as it has to be approved by majority of the users, it is secure and we call it as a consensus. Okay. Efficient. Why it is efficient? It is efficient because calculation is happening at a great edge. It's very fast, all automatic. There is no human intervention. Frictionless. Why it is frictionless? Because we can ask the user in advance their preferences. All right. And as we know the preferences, there may not be any issues later. So it's frictionless. Flexible in the sense because we can bring in and bring off the users at any point of time, okay, in the market. Why transparent? We know that transparency is very important features of blockchain technology. It is transparent in the sense that blockchain technology provides a platform which is nothing but a ledger, which is a digital ledger, I will say, okay, ensuring that all the transactions, that is energy transactions, are tamper proof, okay, and it is audited because all the computer that is connected can easily see whether any manipulation has been done or not, right? So that's the very important part, that a blockchain technology is secure, that the security is very high, it is transparent and also trustable, okay. So some of the key features, if you see, of the blockchain is nothing but decentralization, because you are making decision at your local levels without involving any central entities, and you are allowing your prosumers to trade energy with each other automatically, so at decentralized level. Then it is secure, transparent, and trustable, as I said. Some more features, if you see, the smart contracts, as I said just now, that the smart contracts are self-executing contracts. That means I'm a prosumer, there will be consumer. So if I bid through my mobile application, someone will see it and someone interested person will be involving here, and then he will say that I will buy. Okay. So accordingly, this agreement can be settled automatically, and the conditions are predefined, and therefore there is no intervention of any human being is required. Okay. Thereby it minimizes the risk of any disputes. That's very important here. So if you see the blockchain technology, how it has been implemented, it has been implemented in various fashion. One example just now I will be showing you here is the transactive grid elements. So you can see this is blockchain enabled meters. What it does, you can install these meters or these devices. We call it as a sensor. It is just parallel to your breakers in your home. I am not disturbing anything, I'm just placing it alongside. And this particular meter, meters with the blockchain technology will give you how much amount of power you're producing, right? It will help you to get how much what is called prices are there. So the information exchange between from one point to other point can be done through this transactive grid element. Okay, and this is a real life example in a place called Brooklyn. So Brooklyn has this kind of arrangement where the prosumers are selling and buying electricity through peer-to-peer energy trading, and this microgrid is known as Brooklyn microgrid. You can go through, you can see how this locally generated photovoltaic can be sold in a New York City. All right. So this is one example here. Brooklyn, see, they have a rooftop panels and they can buy and sell, and it is through the peer-to-peer contracts. And who is the broker here? That means the platform who has given. The company name is LO3 Energy. So they have given here. Now, see the evolution. We first talked about tokenization. That is how we are integrating the information to the grid. Then we have a peer-to-peer market. Then we have prosumers, because if market comes, prosumers will be encouraged, and more prosumers you can see in the market. And all the prosumers, they all together, they constitute a community microgrid. This is the principle of LO3 Energy, which is a aggregator for the Brooklyn microgrid. So transactive energy market, therefore, if you see peer-to-peer is one of the objective under transactive energy market. So transactive energy market says that you must have a local power production, and it should be more into renewables and creation of local market. So creation of local market is actually, is a platform where the peer-to-peer trading can happen. Okay, so this is one of the case study where you can see that a day ahead operation and real-time operation can be done. I already talked about day ahead and real-time operation. So anyone can take part and settle their contracts. And maybe day ahead means tomorrow you want to sell, today you are bidding, and it must be ensured from the generator side. It must be ensured that you should not overbid, because overbid, for example, you say that tomorrow I can generate and sell a 1 megawatt. Certainly you could not, then penalty will be imposed on you. Okay, so penalty factor consideration is very important, PF, right? So this is one framework that will help you to do business. One more important issue that you will see in peer-to-peer is the loss allocation, because if you do neighborhood transportation, losses will be less. But if you do transportation of the energy from a far end, maybe 26 node to 33 node, that time you have a more substations you are crossing, for which you have to pay huge you know uh, penalty in the form of losses, because losses is also amounting to some energy, and it has some value. Okay, so the question is who will pay these losses. So the participating you know players will be, actually they are liable to pay these losses. For example, prosumers and consumers. If prosumers or consumers are in the trading business, they must be paying these losses, not the slack buses. Okay, so this is one typical type of table which can help you to understand what is peer-to-peer transaction. The transaction one, at transaction one, at 11 a.m., one substation is buying, that is food node 4, and selling node can be 6 or 16. Okay, and they are using phase A. There may be phase A, phase B, phase C, because we know it's a three-phase system. So any of the phase you can use, and correspondingly how much amount of power to be transacted. So one can easily model mathematically and perform load flow, because load flow is very important to calculate the losses. One more case study that you might be interested to know is the frequency regulation, because microgrid is forming here at the local side, and it has a peer-to-peer trading between several prosumers here, DEG, Solar, Wind, and BSS. And there are so many consumers. Their agreement is settled through blockchain technology, where any excess power that they have, they are selling it to the DSO, and DSO connected to the TSO here. So this is one more example. So the blockchain based peer-to-peer trading is very important. Therefore, I already spoken about the blockchain technology here. So if you see decentralization, I spoke about, because everything is happening at a decentralized level. Openness, because you have to trust the algorithm. So security, trust, and transparency is very important. As blockchain has this, so we can use it for the peer-to-peer energy trading. automatic execution of the contracts. As I said, bilaterally, two participants, prosumers and consumers can easily transact this energy, and the amount can be settled at the known prices. So that's safe, secure, and automatic, I can say. Now, if you see the history of blockchain, the first generation of blockchain platform was, by the Bitcoin. So Bitcoin is the first platform. Then Ethereum has came up in the market. Then so many other generation three we have Cardano, Polkadot, Solano. Here we also have a Power Ledger. Now it is important to know that India also has a three pilot project where the peer-to-peer trading is being encouraged, and Power Ledger is one of the market investor, and they have been involved in peer-to-peer trading implementation in Uttar Pradesh. So I'll discuss this in the next slide. Now, how this blockchain works, as you all know that energy transaction is very important here. So at first, prosumer has to generate electricity. Maybe they have a rooftop panel, so they will generate. Then a prosumer with excess energy after their consumption, it can be offered to be sold on the blockchain platform. Once prosumer with excess energy offers their bid, then there's a smart contract execution, as I said. So smart contract is nothing but the contract when this prosumer will say that I will sell X megawatt of energy, X kilowatt of energy. That time it will be seen by the consumers if they are also associated in the market. And based if he has a concern that yes, I will buy this power, it will be settled automatically through smart contracts. And this transaction is recorded on the blockchain, and the updating the energy balances of both the participating parties. Okay. Then the energy is transferred through the grid from seller to the buyer. So after that, the payment is automatically settled through blockchain. Okay. So this is how the blockchain works in brief. So if you see, this technology has been used for energy sectors at some list I've shown here. This blockchain can be used for peer-to-peer trading. It can be used for transaction settlement at the wholesale market. It can be used for DEA generation and service coordinations. It can be used for cybersecurity and so on. This is a long list. Okay. Now let us talk about the blockchain pilot projects in India. If you see, uh, these projects especially by some of the leading power sectors. Here, the project one, which is established in the year 2020 in Uttar Pradesh, the first in South Asia, you can say. Second project, which was in Bombay by Tata, Delhi by Tata Power Delhi Distribution Limited. Then we have in Calcutta. So we have three pilot projects which I will talk about. This pilot projects is just to see whether the peer-to-peer trading actually work or not. Okay, and there is no practically any billing. Only shadow bill has been generated. All right, because it's a part of the pilot project. Now let us see in Uttar Pradesh what has happened. Here, the scope of the project is to demonstrate that whether peer-to-peer trading through rooftop panel will be accepted in a country like India or not. For which India Smart Grid Forum and Power Ledger, which is a blockchain platform, they have collapsed in the year 2020. And their main objective was to give more flexibility to the prosumer and give incentives, okay, for having a rooftop photovoltaic panels. Also, the objective is to give opportunity to the utility, that is the power sector, to have a gain, the financial gain, the revenue earning for wheeling charges. Wheeling charges is nothing but the charges due to the transportation of energy from one point to other point, or from one peer to other peer. So as a architecture, if you see, they have selected 12 participants in the Lucknow city, 9 prosumers and 3 consumers. It is limited due to your COVID wave in 2020. So under this scenario, this is the brought from the grid power in kilowatt hour brought from the grid. Brought from the grid, this is the corresponding rupees. This is the amount that they have recorded. They have buy and sell between the prosumers, 9 prosumers and 3 consumers. And this is a corresponding amount and sold to the grid. excess power sold to the grid, and these are corresponding, rupees, the prices. So you can see this has been observed that, well, it perfectly works well. Okay, with 9 prosumer and 3 consumers, they are going to upgrade it very soon. And also you can see the wheeling prices, the transportation cost at that period of time was, settled as 0.92 paisa per kilowatt. That means per kilowatt, 0.92 paisa you have to pay if you are using the networks to the utility people. And the transaction charges is this one, 0.42 per kilowatt hour. And this is being distributed among the prosumers and consumers which are participating in the market. So overall, if you see, there are lots of benefits of the transactive energy market, P2P, with a very, one of the very important aspects here, because uh, this will encourage more local energy production and to be consumed at the grid distribution level, because here your most of the demands comes from the distribution network. If you can fulfill this demand at the local level only, then you don't have to have more power to be transferred from the centralized location, and this will be costly, definitely. So if you produce locally, you consume locally, that's cost effective. Thank you for your time and patiently listening my lecture. Thank you so much. Yeah, am I audible?
Sir. Yes, sir, you are audible.
Yeah, thank you.
Thank you, sir. Thank you for sharing your valuable knowledge, sir.
Hmm.
Now, now I am requesting every participant, if you have any question, please, you can raise your hands.
Tanmoy has joined. I don't think so.
Participants, please open your mic and ask the questions.
If there is any query, you can ask to the expert. So he is there to answer your queries. Okay.
So Tanmoy, you joined finally.
Yes, yes, yes. Myself and Professor Monoranjan both have joined.
Oh, Monoranjan is also here.
Yeah, yeah.
Okay. कहाँ है मनोरंजन? अरे कैसे हो? Oh, both together.
Yeah.
Good. So fine. गला बैठ गया, 2 घंटा हो गया ना almost.
No, it is truly hectic. I mean, 1 hour 45 minutes to say at a stretch is very difficult.
Okay. Okay, I will be happy to answer some of the questions if you have.
Yes, yes. If there is any query from any participant, kindly raise your hand and ask the question. However, it is not required to raise your hands because I have allowed everyone to unmute yourself. So you can just unmute and raise your question over here.
Hello. Yes, am
Yeah.
I audible?
Yeah, yeah.
Yes, it is a very comprehensive talk regarding pricing, trading, and others. We are really not aware of this too much, but
Yeah.
really want to know also that how it is happening. So my first question is, as you were talking about that, it is very small participants. So from university or any research institute, may we
Yeah.
participate in that? That how small things can be like if the small DC microgrid and other things can how it be most effective manner in cost effective manner. I mean, how do we calculate our cost and how do I distribute? Because in R&D section generally in our university bar otherwise we as it is grid connected and there is a question of in West Bengal also the question of net metering and others, so
Yes,
we
yes.
cannot even estimate that how much we are contributing to our everyday or what are the amounts of total energy we are producing and how much it is consuming.
Yes, yes, yes,
Although
yes.
in our laboratory, what we have done as absence of net metering and others, what we are that all the things we are running in solar. Okay, but the
Okay.
things are when it is really a C kind of thing, and others really we are feeling that whether we can support or not, and how much we are support in our small system. That is very important. Although we have purchased one smart grid, one or a smart inverter once
Hmm.
in 2018-19. So may
Okay.
we have that opportunity or any support from your part, or that my question is.
So your question is very also comprehensive. See, peer-to-peer trading is now happening at very local level, right? And we just started doing research on whether we can, how much benefits we can take out of it. Yes, most of the loads that we see in our buildings are AC loads, right? And we are bound to convert this DC production into AC. And therefore, as you can see in the Illinois Institute of Technology, what they have done, they have
Yeah,
just
better.
divided the floors, like
Yeah.
DC floors and AC floors. So you can find that there's a lots of advantages. And one of the example, even though you see the number of prosumer that has been selected in CSS Calcutta, this Calcutta supply electricity supply, and this UP and Power Ledger, the numbers are very small. and and then if you see the same thing in Brooklyn, the numbers is more, not lesser. So if you see the entire phenomena, what is happening in Brooklyn microgrid, they are powering both DC as well as AC loads. If you see DC loads, lighting loads nowadays we have, we can easily install in our building. So basically the main motivation is to use more and more green energy rather than the cost. Right now, we didn't talk about cost, because cost will come when the policy will come. If you talk about net metering is like 2 rupees per kilowatt hour. If you see in UP in during this pilot project, but then when it comes to residential and commercial building, it goes rising up to 8 rupees, 7.5 rupees, 8 rupees. So ultimately, what is the benefit? Because benefit means in the sense we're already getting electricity at this competitive cost by the conventional plants, right? So here the motivation is to convert or to make all the buildings at least have a rooftop panels. Now you cannot take part in net metering if you have a 1 kilowatt or 2 kilowatt. Minimum 5 kilowatt is important,
That
because
is
yeah. So if you have a 5 kilowatt, then you can just give an application to your utility. They will come, they will inspect your solar, they will see its operation, they will give you the connections, and you can sell electricity, and your total bill will come less. They will not pay you, rather they will be giving discount on your this utility bills, overall bills. Work is going on. We hope that maybe near future the complexity due to integration of more renewables and power electronics components will be also reduced.
okay. Thank you for your.
Yeah, thank you so much. Yeah, if there's no more question, I will sign out, because I have to go somewhere. I have other plans. Don't
Yeah.
want.
Okay. So since there is no query from the participant side, so I'll be requesting you to stop the sharing.
Yeah.
And at the same time, I'll be requesting all the participants to turn on your camera so that we can be able to capture a photograph with the speaker. So, Dr. Sanjay, thank you very much for sparing your valuable time with us. In fact, you have shared your difficulty, and obviously we understand also. But still, you have kept your words, your commitments. We are really thankful to you.
Thank you, sir. Thank you.
Thank you, Manoranjan. See you soon. Tanmay, thank
Yes,
you so much. Thank you all
yes.
the
Sure, sure,
participants
sure,
for
sure.
patiently listening. And today is Sunday, and you have given your time. I can see 78, 82 participants all around. It was
Right.
92. That's a very huge number. We cannot get it even online nowadays, right? Our
No, it is
students
true.
also, if you compel them to listen, they will not listen.
No, no, no.
Okay.
Participants are the main stakeholders, right? So they have supported, and that's why we are here today. So whatever, thank you very much.
Yeah. Thank you so much.
Okay, okay,
Okay.
okay.
See you. See
Bye.
you.
Yeah.
Bye. Bye.
So for the participants, there is an important announcement. Tomorrow we will have our first session started at 9:30 instead of 9 a.m. So kindly join the sessions for day 3 at 9:30 a.m. Thank you.